Okay, I think we then start off. Thank you for coming here this late afternoon for this session with the name Using the Power of Salt alongside SUSE Manager 3 in the all-new shiny Lessons Learned version. First, can you click please? First, I give you a little overview about the agenda, then I will introduce myself and my fellow colleague here. I give you a little overview about SALT basics, so everything I want to, if somebody's in here not knowing what SALT actually does, so I give a little overview about the components we're going to talk about. Then I give you a little bit of history, why are we getting off at SUSE Manager and SALT, and what was our goal with that. Then I have to give you an insight of how we do that, basically, what's the configuration side to do it. And then we're going to look into configuration management and software management. So because we have split these two types up. I'm going to talk about risks. And then at the last part, I'm going to show you some cool stuff we invented or it's maybe used for you if you want to do similar stuff. Okay. My name is Andreas Linden. I'm from Switzerland. I work for a retail company in Switzerland called Coop. Here's one more. Yeah. We have like a lot of, on the left side you see all our retail branches, so our retail basically brands. In the middle you see all the wholesale, so the retail is just in Switzerland, the wholesale is all across Europe, and of course we have our own production sites. We have all over like 46,000 employees in retail and another 38,000 in wholesale and production. We run 2,250 retail stores and 226 wholesale and production sites. Yeah. Okay. With me I have Bo Jin from SUSE.
My name is Bo. I'm a sales engineer at SUSE Switzerland. So I sold SUSE Manager, and now I'm learning SALT.
And he's going to ask questions during the talk if something I say is not totally clear. So he's going to ask a question, or if you like to ask a question, just go for it. Yeah.
One thing is the motivation why we think we want to talk about it is because last year SUSECON Prague made it first time.
Yeah.
And after that, the feedback was very good. A lot of customers, new customers, were asking them if we are using SUSE Manager, and so how do we do that at least in daily job, in daily tool operations, how can we connect that with speed and so on.
Yeah, and not in a whole new art, in a whole new world, right? Just with your existing IT. So make use of it in an existing IT, not something you want to build in the future, right? Yeah.
This is the second version.
Yeah, it's the improved, shiny, new second version.
After more lessons learned.
Yeah, more lessons learned. Okay. I try to point out these lessons learned through the document, to the presentation you go show. Okay, who here has runs SUSE Manager 3 with SALT minions already? Who has made use of SALT within that universe? Perfect. Okay, we go quickly through the components of SALT, just that everybody's on the same page, right? Next one, please. Okay, SALT. These are buzzwords taken from the website of SALT. It's infrastructure management, data-driven orchestration. This one is really, really big. And you have the fundamentals like remote execution, configuration management. This is what the other stuff is powered by, and much more. So you could say it's a central systems management because it's the one single point where your central system is going to be managed, right? Okay, next one, please. So at first you have your SALT master, and if you have a SUSE Manager 3, you already have that. It sends commands and configurations to your minions, and minions is on the next page. It's basically your server. You could also say agent to it, but they say minions to that, okay? It receives these commands and configurations, apply to themselves if there are questions to do that, and they give the result back to the SUSE Manager or to the Salt Master, right? Okay, next one, please. To enable Salt to do that, they use something called execution modules. And basically what you see here is the module disk, and you have a function in that module that's called usage. And what that module basically does, it gives you the usage of the disk of the underlying minions that you have selected. And before you have that star, which means all the servers are selected now. Okay? And it doesn't matter if this is a Linux minion or a Windows minion or a OS X minion, they're going to provide you with the information the same way. The module makes sure of that the information is in the same way as it comes from Linux. Of course, not all the commands can run on Windows like they can run on Linux. There are modules that not want to go to load if you run them on Windows. So, next one, please. So, the next thing is formulas or states. I don't use the word formulas mostly, but this is basically a description that you can have when we have focused on this Vim. It's a very simple one. It just said Vim is basically the state ID, and it uses the package the package installed module for that. And what that basically does, it installs Vim. It makes sure that Vim is installed on a system. Okay. You can apply such a configuration to a minion, and it will always install Vim if you apply it to it, right? And you have a second example here that do install Apache and make sure that the service Apache is running, right? This is like an imperative description of an installation. Okay. Next one, please. Okay, then you have grains. This is really cool. Grains are basically system variables you can use. There are a bunch of them already on the system, like Python version, or what else? Host name, domain name, and a lot more. And what you can do with that, you can select minions by this grain. For example, you can say, have me a run over all my servers that have Python version X, whatever, and you are able to run a command across these minions, or you are just able to find that minions that have that specific version. Okay, and this is what grains are for. Next one, please. Okay, now the top file. As I said, you're able to apply certain file states to minions to install Vim, for example. Another way to do that is use another functionality of the state apply module. That's called high state. If you already know Salt, you know what a high state is, but for other people, as I said, one way is to apply a configuration file to a minion, and the other way is to use the so-called top file for that. So you just need to run a high state then on the minion, and the minion gonna load up this top file and makes the filtering for you. So what that does, basically, the minion applies this top file to himself and says, all the servers, so star has to install this Vim file, the scripts file, and the user file, whatever is then in there, right? And all the servers with web in their name, they install the Apache, Python, and Django states files with description of installation in them, right? And the DB, when there's DB in the name, you're gonna get MySQL, okay? So that's for the basic functionality of what we covered today. Next one, please. So why? First, we had a really simple thing that we needed. It was to patch Linux on Power platform. And the solution we had in place was Novel ZCM, and they don't have an agent for that. And then we looked into SUSE Manager, who was I think it was the only, is that right? The only solution for Power at that moment with SLES. Yeah, we looked into that, and we saw they came up with the new version 3 with already Salt. And then we had a look into Salt and said, hey, this could be a good thing to make use of because before we had configuration of servers with a script, so with an autoyast script at the end of the autoyast file. And then we did installation of RPMs with configs in that. And we did that one time, and we shipped the servers off, and the drift started, right? because everybody's root on the system, so the application owners are root, they install the application and they do tweaking until the system is running again in the baddest way. Okay. Now, as a lessons learned here, it's super to have an automation platform, like one automation platform that everybody's using, and not I have some scripts there and the other one has some RPMs there, and everybody gives a little bit magic when they do things. So that's basically a good thing. And the other thing is, if you're able to write salt states on a daily basis, just you gotta be able to like document your installation directly into Salt, and it's easy readable. It's not like there's a flavor to every script, right? Where you have to understand how a person wrote that script. But in Salt, it's easier. It's easier to read, and the best thing, you can use it again to install the same thing on another machine. Okay. Yeah, please. Okay, what were our goals with that when we started off? Okay, we want to have system equality, so all the systems should be configured the same way. That would be the dream of it. We want to prevent the configuration drift, so we want to roll all the changes that are not good, roll back to the state they were. With that, we want to be flexible and scalable, of course. And we want to automate also complex installation, not the simple stuff. We also want to really the complex stuff where it gets it's different because you have to document a lot and you have to use this script, this command, and that. And we want to have all the also complex installation to be automated. And out of that, we wanted continuing quality, right? Good quality systems that are stable. Okay. Now, how to do that? SUSE Manager as Salt Master with Git. First, you have to develop knowledge, right? It's a high entry step. You need to learn Salt and how to write Salt states. You need to learn Jinja. You need to learn, at a certain point, you're gonna need to learn some Python because you want to extend these modules you have, because you have special needs or special software that has no module to support you, so you have to write that yourself. It's not so complex. You're going to learn it. There's a lot of code out there you can review and make use of. And of course, it's a different approach. I don't know where you all where you're standing, but you have to think global and you have to think about automatability. Is that a word? Yeah? Okay. You have to get a feeling for that if something's not automatable. You should not build niche solutions, and you don't, of course, you don't do manual changes on your systems. You do everything in states. Okay, then this is political. You have to get everyone on the same page, because if you have a lot of other departments doing things, they do their own way, and you have to get them on board to say, hey, we have a super automation platform. There's a lot of samples out there, and you can hop on, and we help you. But there's a lot of energy going into this, where you wave the Salt flag or the configuration management flag, right? And the other thing is the Salt version is dictated by SUSE. And what we learned here is that it's now quite actual, and it's got to get updates quite a few times during the year. The thing there was when we started off, we had like version 14 or 12, 15, I think. And then it came 14, and there were a lot of bugs in the modules, and there were a lot of developers demanding new functionality they see online, because if you go to Git, you always see the newest things, and you don't see the old stuff. And this was a special version even, where you was not able to see in Git the version we had. But thanks to Joe Werner, this is going to a little bit forward now, and it's quite actual now. It's not the newest version, but it's quite actual and stable. Okay? Yeah, I've heard that, but that's version 4 SUSE Manager, right?
Right, but the Salt version is across all SUSE Manager versions.
Yeah.
So once it goes out, it's out
Yeah.
3.2 and 4.0.
See, perfect. They do that fast now. Super.
Why did you know that? How come you SUSE Manager developer?
Yeah, he was with SUSE Manager. I saw him last year in a SUSE Manager talk. Yeah. Thank you for. Okay, how do we do it? Okay, at first we have our SUSE Manager with Salt, and we install, we have all our states and templates put into a Git repo. Okay, and that Git repo, the master branch of that Git repo, is basically our live configuration. And we disabled pushes into that branch totally. So there's no push into master. The only way to get changes into that branch, and changes pushing out, because if you push that, if something is in master, it's going to be rolled out, right? Just to make that clear. If you want to get a change into this, this master branch, you need to create a feature branch where you're going to be merging into that master. And you need another colleague to allow that. So you make a merge request, and another one going to look over it and they say, this is allowed or this is not allowed. And I'll tell you later on how and on which basis they do that. They don't have to understand the code, it's just simple rules to follow. Okay. Next one, please.
So, by the way, this question is asked by many other customers who say that if we also use Git, how can we control this workflow? Different applications, right? State files, contribute, and push up.
Yeah. We have at the moment like 25 people developing on Salt over that Git repo. And it's kind of within the department self-containing, so developers control their own states by themselves, and we ops do the same. And we meet every week to talk about new things we want to roll out, or if they have demand on the platform, and if we have saw something that's not so good in the software development or in a state. When they, for example, sometimes they make stuff like moving files to NFS. And they get a lot of load to that, and because they search for a quick solution when it's not so good. Then we talk about this. It's called the DevOps board, and it's a good thing to get these departments together as a start. Okay. What do you need? You need a Salt Master. If you have SUSE Manager 3, as I said, you already have that. You need to install a Git client on that SUSE Manager. We started off with Git Python, and we found out that it's not so good. So we had started having problems with Git Python, and we switched to Pygit. I think it's already, correct me if I'm wrong, I think it's coming with the installation of SUSE Manager 3 anyways now. I'm not quite sure about that, but it's easy to install. And you have to make configuration into etc salt master configuration file. And this is one thing, you need to add Git to the file server backend. You should not remove roots, because SUSE Manager is also having state files on the SUSE Manager in another directory. And if you cut that off, the SUSE Manager won't work again. Okay, so you have to let that in. Okay, then you give the Git FS provider, which is the Git client on the SUSE Manager. This is going to pull the state files from Git for you, I think every minute. You can configure that, how often that is done. GitFS remotes is your URL to your Git. And if your Git is with a self-signed certificate, you need to turn off the SSL verify option. Okay? And then you run Salt, run file server update, and you're all set. Bo was asking a question if it's needed to restart SUSE Manager or restart Salt Master, but I don't think it is. But not quite sure. It's possible that you need to restart SUSE as Salt Master too. But I'm think you don't need that. Okay, next one please. Okay, why not using the Salt Manager SUSE catalog functionality? Because you are able to do state files within SUSE Manager in the GUI, right? And they extend this functionality through time. But when we started off, it was no way to go, because in the first version there was no functionality. In the second versions, we were just able to do, I think, state files. So everything with the SLS ending, so no templating, and no other files. I don't know how it looks now, but as I said, we had a lot of people working on that, and we don't want to give them access to SUSE Manager. As there's a lot of access they need. They don't need just looking rights, just viewer rights. Yeah, and another thing is we want that transparent change system through Git, because we are able to see who, when has changed what, and we are able to roll that back at any time. And this is something you're really gonna like if you have that in place. Because if somebody asks you, how is something configured? You go to Git. Go to Git and look it up. It's there. And if it's there, it's configured outside, right? Usually. Okay? And with that, you have this single point of configuration where all the configurations goes in. And not 5 points or so. And we use this solution. We use in other products too. We now go with CASP and do deployments over Git. So this GitOps thing is really something we like. So we have learned to like, I should say. Yeah. Next one, please. So should I explain that a little bit more? It's basically you putting instead configuring something, you do configuration into a Git, and you have a mechanism pulling that from Git and pushing that out, whatever that is. And it means you do operation by Git request. So you have always something reviewing your stuff, and it's transparent. It's not no shady something configured somewhere on the server that is not good.
And do you have some validation steps before it gets merged?
Yeah.
Because just reviewing the code like that is not easy.
Yeah.
But all mistakes.
Yeah, of course, because the one guy that deploys it is totally into it, and another person reviewing it is not. Yeah. And it's not the way the code is written or what's inside the code. So what we basically do is, as I said, you have in Git you have these feature branches, and you are able to check these feature branches out on a server and test that and verify that. You just check out the feature branch and run your states locally on the minion. I'm not going to show that because that's a little bit too far, but basically you start off in development, right? And only if that works in development, you go to testing. And if you are in testing, then you go to production. And then the thing should work. And you always go back if something's not right. You go back to development, right? And you are able to test locally. But we have no automated testing for that state because that would be a little bit too much for that matter.
How are you doing that? You're having several SUSE Manager instances, one for production, one for...
No. I'm going to talk about that, okay? Because that's not possible. Yeah, but I know that you know that. Okay, next one, please. Okay, this is something that's maybe good to know for you. If you have your runners, that's a part of Salt. We're not covering totally, but it's something SUSE makes use of. These are basically stuff that runs sometimes when something happens. Just to make a quick introduction to runners. If you want to make use of that, you need to enable them because they disable that for you. Because they set their own path. And automatically this disables the standard path. And what you have to do, you go into SUSE Manager conf and add your path as well next to the one that's already there, so that you don't cut off SUSE Manager. You can easily add another path to the file. The next thing you want to go doing is you want to set the top file merging strategy to same, because SUSE has as well a top file, and they should merge, or you get a warning if you don't configure that. And then this is something that was a problem before. I don't think it's a problem anymore. On all updates, they're going to create you a top SLS file at SRV salt when there's none. And before this ends up in your Git repos not working anymore. And you have to remove that on every update. Because they think that you have configured SRV salt, and they create a top file for you with no opt in it, or empty. It's empty, basically. And this cutoffs you get. But I think in the last versions that has stopped doing. So that's, you know that, yeah, doesn't happen anymore. But you create the SLS file, but it's not interfering with the Git backend. But you don't create it anymore. Yeah. Okay. And then the lessons learned. This is something we came across like half a year ago, because we have a lot of state files that could possibly run in a high state. So the theoretical amount of states that could run on a minion is big. That's due to the way we're doing this. So it starts rendering, before the run is done, it starts rendering all the state files through. And this is going to take a lot of time. And this started to take about 10 minutes to just render. And this was too much. And with this parameter, you can shorten that to just that what's really going to be applied on a minion. And this helps us out a lot. Yeah. 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 Yeah, but just read the documentation about it first. Okay? Next one, please. Yeah, there's this documented in SALT, right? Not SUSE Manager. Okay, configuration management, first thing. Configuration manage a greenfield project. That would be beautiful. Then you can have all the cool stuff. But in our case, it was more like, can you press the button, please? More like a jungle, okay? Can you press another button? And the way out of the jungle was our salt grains machete, okay? Because you're not able to set minions into environments, because if you do that, you need to get them out of base environment. This is the first thing you see in the top file. And if you change that, your SUSE Manager is not able to connect to your minions, because you put them out of base in another environment and they don't find them anymore. So we needed another way to do that. And what we done is we implemented our own grains. You can just create a file, etc salt grains, and put your own variables in there. And we do that when we set up the server already, because this is information we get out of a workflow. And the third thing is the configuration, the corporation grain, so to which company this server belongs to. The CSV version is our internal server versioning this is basically a /12 SP2. There's DMZ information, and of course you have the environment. And ENTV means development, and you have testing and production. Then you have flags, where you can flag something, make use of that. There's the high state true, we'll show you later. You have the physical location of the server. Based on this, you can do name server lookups in the right way. And you have a pilot grain, and you have software groups. We'll look into that in the next section. Okay, this is a short overview of our top file. It's a little bit bigger because we have other companies configured in it. But this is basically what it does. It's what it's supposed to look like. If you press, we have a lessons learned there. Could you press the button? Yeah. It's going to be switching. And we don't have global states. We don't do that *F something. So the least thing you need to get states from Git is you need to have this corporation code grain. So not every server is able to get grains, get states from that server. So this is the one thing the least you need to do state applies. The third thing where you get something from high state is the next one. It's a compound matching. What that means is basically the minions, as I said in the beginning, the minion going to use this top file and applies it to itself. And it asks, do I have the grain corporation code? And do I am a CPU architecture x86-64? And if I am that, this is going to push me into this file directory, 002, 01 coop states, x86-64. And it's going to apply every state in there. So every state that's included in the init file. But I'll show that later. And the next one, so on this level, basically, we do configuration management. This is where we configure server. And on the next step, we bring in the environment, and there's where we software. We install software. Okay, next one, please. So these are basically the filters that we have. You already seen them. We have another 3 blocks here and another block there for PPC64LE, so little endian. But basically, what I said here, configuration in a higher level, and the software here. What that means is, in all environments, the servers are the same configured. This is just one level higher. And there's no it has worked in testing, and now in production it doesn't work anymore because you made a mistake in configuration. It's the same configuration all over. Of course, you're able to have something set differently, like other passwords or other security measures, loosen them up within the states, right? But basically, the configuration is on one higher level, not in the environment. Okay. Next one, please. This is what it was looking like, and if you press a button, you see it's gonna be shifted a bit. We put a lot of things we have before in the tree a little bit up, and we added stuff. So basically, we have some scripts, migration scripts, because you are able to run these scripts through Salt over a lot of minions. So we put that in Git as well. We have the state, our own state modules and our own modules in there because they're going to be deployed as well over Git, so your own modules to use. And we have some configuration directory, and we have certificates like the basic open certificates we want to have on our servers. And as I said, in the top file, when we now make that applying to a top file, if you're a development minion, you're going to be thrown into here, and everything included into here is going to be applied on the minion. And and the same is for the configuration management, right? You're going to be thrown in here first and apply everything here, and then you get software and you're going to be thrown in somewhere here. Okay? Next, please.
I need the 1 year to understand this. Before you look at this slide, and you can
I tried to show it a little bit more, because the problem I had when I started off was how to find out how I get from a top file into a directory, and how I do that in a way that would apply to our company, and not just this simple stuff in the documentation where you always see a server that is DB in their name gets a DB file applied. We want to have structure here. Yeah? Okay, and here you see how this init works. So the top file pushes you into a directory, right? And this init file is going to be loaded. You never write, there's something you have to learn if you don't know Salt, you never write SLS and you never write init. You just leave that away and then it works, okay? So what that basically means, you have the path. The path is always with pointer in Salt. To include, it's always with a point. And if it throws you here, it basically loads the init file here. And in the init file, we do the include. And what's here included is going to be run if the minion does a high state. Okay? And we grouped, you see that later a little bit. Our configuration management is grouped into some files. It's not too complicated with no folders. It's basically SSH, it's LDOP, it's basic services, and they are contained within one file. All the LDOP stuff you need is in one state file, and I think we have like 15 or something of them just to configure the server. Okay, the high states. How to run high states on a server? What we done is we had chosen to do a schedule. This is another module. Can you press again? This is what we had it. It was 50 minutes, and now we're going up to 60 minutes because the load on the SUSE Manager was too high to do that all 50 minutes with the growing amount of minions you have. Okay, and what this states, this is a state file, and this is going to apply this schedule on a minion, and you can ask for these schedules that you already have. There's another way to do cron. Basically. And what that does is if you have the grain high state true, you're going to get that job. And if you set that to false, the next high state will remove that schedule job again from the minion. So, but as we found out, the most thing people do is they just remove the schedule, right? They do schedule delete with the job name, and the schedule is gone. Even the high state grain is set to true. But what that also does is when the next high state comes, it creates this schedule again. And we are able to look for minions that have this removed, right? So we do some scanning sometimes and see the minions that had that removed. So, but normally nobody knows how to do that. Right? There are other ways to do that. You could do that from SUSE Manager, so from Salt Master, pushing these high states out, but this is something we don't want to do because we want to have this scheduled through time. So every server do that for himself 60 minutes after starting. So when it started, it does once and then it waits 60 minutes. So you get this perfect load balancing of load coming into SUSE Manager. Okay.
Last year you told about for this scheduling, so to not allow all the minions to start high state at the same time, you did a random delay.
Yeah, we tried that, but that was not working good.
Okay.
Yeah, because that was the way doing it from a Salt Master out, pushing the high states out with a scheduling kind of. Yeah, but that was not good. This works better for us. Okay, software management. Now it's going to get a little bit more complicated because the configuration management was easy. It's flat. But just to have in mind, if someone automates an installation, he delivers like a folder with all the state files and templates and everything he has done in a folder. And we're going to put that folder in this directory you have seen, first in development. Okay? And then we we make an include in init, and we write this file. For example, this is Hybris. We make this entry state. We put the folder in the directory, and we do another state called sv hybris 101.sls. But as I said, you don't write SLS, okay? And in that state file, it's going to be this grain break. We call that grain break, okay? Because only if you have that grain in your grain file, this is going to be included. And the minion gets thrown in this directory and runs everything in here. Okay? So this is basically going to ask if Hybris base in software groups, you can have a lot of these grains in there. If that's in there, you're going to go into the folder and install it. And if you're not, you're going to not install it. Right? These are just empty includes then. Okay. Risks with that. Again. Maybe you know that. And this quote, if there are things automated or robotics come into place, people are going to have fears. They say, this is really easy to break stuff, but who's in here is not able to break stuff in their company really fast? Yeah, this is just a better tool to break stuff. A faster one, maybe. But you have to handle it, and you have to talk to people, and you have to understand their fears and address them, right? Can you get next? And what we built is our code of conduct with that, okay? Because there are a lot of problems that are not solved with GUIs here, because we make pushes into Git and we make mistakes, and we have to make sure that we detect these mistakes before it runs in production. And if it does, we have to fix it, find it quick, and roll back. So we're going to have that. Okay, the first thing I said, we have this 4I principle where people going to review the code. That what I said to you, they don't review the code itself. They just check if you started off in development and go then to testing, and not do that in one push. Because you are able to push new code into development and testing and production at the same time, or make a fix quick as a quick fix for something and push it in all environments. And this is not going to be good. So this is something a reviewer would not allow you to do. Okay, and we're not changing configuration of a server on a daily basis. So this is something you have in mind. This is not. This should be bulletproof when you roll it out, and then you apply just small fixes to it. Okay, then select minions top down. So given by structure, as I said, in the grain way, to select minions go from top down. Clearly separate state file types by name. So clearly separate configuration management and software management, as long as it works. But you want to get to a point where software, not mostly good software, going to need you to configure on a system level something. And what we do then is we documented in the software that this software state has another configuration in a configuration management state, and we do that then again with this grain break and configure something different. But I'm happy that we have had that down to about 20 or 30 occasions where that was needed to do, and I hate all of them. But and you're not going to see something when you go with Docker. This completely, that is not possible anymore then. When it's containerized, it's not possible to change underlying system configuration. So this software is going to be fixed anyway. But yeah, this is something you don't want to have and you want to clearly separate from each other. Then document the state owner. You wrote it, you own it, and you're responsible for it. And you have to ask somebody if you want to change something on their code. So that's basically how we handle it. And follow the correct integration path, as I said, from development to production, through testing, of course.
By the way, because you mentioned the risks, there is one fancy command to solve before you can execute it as a user and your data center is not.
Yeah, there are a lot of them. There are a lot of great ways to do that.
With sort.
Yeah, of course.
One, which is you only ever want documentation written.
Yeah, you can start a fork bomb with CMD run.
System because don't do that.
Yeah.
Happen to many sysadmins who started with work.
Okay.
If you issue sort, asterisk means all machines, all minions to system holding name dot function name.
Yeah. Then everything gets rebooted, and you end up with a really fresh started environment. Yeah, if you use, that's something good. If you use SUSE Manager functionality, they don't let you do that. You have first going to a test equals true run to that they let you apply that. But if you're doing like this, it's possible. Yeah. Yeah. Okay, lessons learned. The disk state. This is something we pulled off early because people are starting to create salt states and they want to have it like they're used to. So we have our /12 SP2 with ButterFS, and we needed to mount disks to that for the application. Okay, and this is something in Salt is a bit difficult to do, so we provided a better solution for them to start off. So the only thing they had to do was they given us this configuration, and each of these blocks are basically a mount of a disk, and all they have to do is mount a big enough disk to the VM before they start it, before they configure this. And this for example going to create the LV, the VG, the LV size, name, and the mount point where it's going to be, and how big does it is. And they just have to add these numbers up and put a disk on that machine. Maybe you put a third more on there. And I'm going to show you how the state files that make use of this is going to look. Okay? Yeah. Yeah, that's we had troubles with Oracle people. They want to have a mount and then another mount on top of that. I don't know why they want to do that, but they were strict about that. They want that. Maybe someone can fill me in on that, because I would say that's not. I don't know why. But what you basically do, you run this twice. Because if that state runs, it's not able to determine the right. Yeah, as you see, you can define the disk here, and you are able to do in the next block another disk. And this is not ends on 3 mounts. You can have multiple mounts, but you have to provide the disks. And the thing is, where you maybe get problems is if these 3 or 4 disks are not the same size. Because you don't know if you set that up, because we want to do that automatically. So from a staging point until finished installation, this goes automatically, right? And you not know which disk is which. So if they are all the same size, that could work.
It
Yeah.
depends on what it is, but I think for
Yeah.
One controller for Shapana data, you need another one for Shapana
Yeah.
dot, and
But you don't have so much. Do you have a lot of SAP HANA machines?
yes.
Okay, yeah, then you're gonna need that. Maybe you can make use of it. Okay, next one, please. Okay, the first thing we do a import of that for the state path. The first line is something we use in a lot of salt states because we want to move them around in a tree, and this is just a relative import path. This SLS you see, so you set state path is the variable. The SLS is like a global variable you can use in salt, which basically is the path of the whole state file you're in, including the state file name without SLS. Okay? And what we're going to do, we split that on point, and we removed the file name of itself. So we end up with a path to that directory you're already in, and then we join that with slashes for an import, because an import in this YAML command here needs to have slashes in them. Okay? This is something you can just copy and use. And the next one is an import YAML. So we're going to import this YAML you see before. And we have that then put into this variable ePaper disk. Okay? Next one.
I always say Joomla is something you cannot learn, just copy this.
Yeah. Yeah. Yeah, no, you can learn it, but it's, yeah. Okay, and this looks complicated, but it's not. It's just two. I had a hard time to wrap my head around this as well. These are just two for loops looping through these blocks. Okay, and this just makes sure that you don't forget to configure something. You don't leave any blanks. It starts working if you do that. Okay, next one, please. Okay, the first block is we're going to create a partition here, and we need 3 states for that. The first one is a module we write by our own, because we needed to fix a bug in the next one. Okay, this is really something we need to pull off before that works, and we had a hard time to find that out. It was the partition mcopart module uses parted on the system to do these partitions. Okay, and if you do that in VMware, you're gonna get cut off a chunk of disk from another disk, and you end up with a corrupt partition table. And you hang it to a VMware, you get a corrupted disk. We had that problem that parted was not working at that moment with that version. Maybe that's fixed now. The fix for it was just do a fdisk W on it, and it was fixed. So we just go to check if there's already a partition. This is the first line. Is there a partition? No. We're going to apply the fix. We create the partition, and we set the ID. We only do that if the partition already exists. If there's a partition on that disk, you don't touch it. Okay? This is going to run nothing if there's already a partition. Next, please. Okay. Next is we do PV create. So we do a physical volume creation if there's not already a physical volume there. The next is we do volume group creation if there's not already a volume group there. And we do logical volume create if there's not already a volume. Okay? You get the ID. Next, the next is we create the block device, and then we mount. This is basically the command to mount. And if you set persistent to true, you already get the fstab entry with that. And you're finished. And if you run that once, it's going to do that all for you. And if you run it the second time, it's not 0 states. It's going nothing out of it. Okay? Next one. Okay. I have to speed up things a little bit up. Lessons learned versus traditional detect and alert. This is the problem is here. We have the self-healing containment within Salt where you own everything and you own the service. And before we had something not working, we alert that and someone come to fix it. And this is a bit difficult because Department of Monitoring came to us and said, this is not good. If you fix that, nobody gonna know. Okay, and then we have some examples here. Is this a good idea? This is SSH. We own all the SSH files, and we here this is a blob. That means you keep this package installed, you keep the server running, you make watches on these 2 files as well. And what this basically does, if you have changes in this file, so someone messing with your SSH configuration, the service is going to be restarted. It's turned back to the way it was, and the service is going to be restarted. This is what these watches do. Okay. And in my opinion, this is good. This is something we like. Okay. The next one is something we don't like. This is basically taken from an installation where somebody had the idea, and it was me. We could start 15 Java Backoffice instances, and this is why the value name there is a variable. These are 15 instances we're going to start within one run. So we install 15 of these Backoffice instances, and we started them off. And it's also named hold running. So on every high state, if something fails, it's going to start up this. And if it then fails again after 20 minutes, you have always a change, but no one's going to detect that. And this is something you should not do. This is basically taken out of another state because this is just run once when the service is installed and never again, just to kick it off. Okay, and then you have to do it in another way to control your stuff. You are able to do that in Salt with reactive stuff, but this is going to be too big for today. Okay, what about high states and changes during maintenance window? This is the next thing. They said you do changes you do high states on machines that are in maintenance. We have BMC Patrol, and we set maintenance on servers, and this should no changes happen then. So this is something we're not implemented yet. This is something we think about or talk about a lot to do. And what we basically did, we made a wrapper around the binary of Patrol, where we can then use the whole functionality of this binary in Salt. And now you're able to check if there's maintenance within Salt. That means we could then do in our include files always a check if there's maintenance. And if there's maintenance, we're not going to run these. We just run this. And if there's no maintenance, we run these. Okay, all this is basically the system configuration. You see the groups now, okay, that we have. And as I said, if there's maintenance, we're just going to report maintenance. And we have another functionality, get the maintenance info, so who sets maintenance, how long, and for what. And we're going to grab that information and just echo that out. It ends up in a change on the minion. And the change, we're going to detect on Elastic. This is the last thing we're going to show you, just quick. Logging. First, we did a mail returner if changes happen. This is something you find in the internet. It's well documented, but it's not good because we stopped that about 3 or 4 hours into the testing because it gets annoying if you get mails when changes happen. But the idea was good. And we took that, and another thing we tested was the returner, the Elastic returner. But the Elastic returner always gives you all the runs, even the ones with no changes and no errors. And this was just too much information to look through. So we just want to have the changes and errors. Okay, and what we built is our own returner, and it's basically a reactor returner. So, or you can say Frankenturner, because it reacts on every job a minion has run. Because when a minion is finished running a job, it reports that back to the SUSE Salt master with a job ID. And what we then do is react on that job, on every job, and we scan that job for changes and errors. And if there are changes and errors in there, we're gonna return that to an Elastic. And now, so we fixed that now. We don't send them to Elastic anymore. We send it to a Logstash. And with Logstash, you don't even, if you know that, you don't even have to install the Python Elastic extension, right? You just send it out. Okay. And what you get is basically you get the time when something happened. You get the minion name of the server that has a change or error. You get the master that it's connected to. You have the function that it's run, even if it's a high state or it's a state apply. You get if it's a change or an error. Error is always superior over a change, because if you have both, error is going to be superior. You're going to get a count of how many changes there were, and you get a count of how many errors there were. And if you open one of these up, so on the next page, you're going to get, of course, the whole job information, the whole dump, basically JSON dump, And what we implemented now is, because it was a hard, if you even know there are 4 changes, but you have to find them in the dump. And so what we implement is we're going to give you the information, the state ID information of the state who has the changes in them, and we have that as well for the errors. Okay. And I think this is it. Next. I think we're through. We'll run a little bit late, but maybe you can approach me or Bo during the session, the next sessions, or during the... It's party now? Yeah, maybe then tomorrow. If you have a... Yeah, I'm planning the party, of course. But if you maybe you want to don't talk about this, then. Thank you for your time, and enjoy SUSECON. Thank you.
Thank you very much.